reflection of sound waves. The presentation is prepared by the Ademola Oyetunji, Osun State participant. You can email me at demolaoyetunji@gmail.com. Good day, learner. Have you ever wondered why you hear sound few seconds after you have produced the sound? Most especially when you are at a distance to a barrier like a high wall, like hill, like cliff. These are no wonder. These are called reflection of sound. Remember that in the last class, we talked about the production and transmission of sound wave. These sound waves, as they can travel from one place to another, when, like other waves, they meet a barrier along their traveling path, they bounce back. This bouncing back of the wave is what we call the reflection of the wave. And this reflection of the wave is what we describe as an echo. Echo is the reflection of sound. These and other uses of echo is what we are going to be taking through in this video. Good day and let's go. The learner outcome. By the end of this video, the learner should be able to 1. Derive a formula velocity of sound in here using reflection of sound that we call echo. 2. Solve simple problems on reflection of sound in here. 3. Define an echo. And 4. Discuss the applications of echoes. As you can see on the board, the cardboard, the stopwatch, the listener, and hide wood like the drawing board is used to set up the reflection of sound wave as the bouncing back of the wave. Sound, like all other waves, obey the law of reflection. The reflection of sound is called echo. The incident sound, the reflected sound, and the normal all lie in the same plane. The angle of incidence is equal to the angle of reflection. So whenever sound wave meets an obstacle along its path, it bounces back. So if the angle is measured, we are going to see that the angle is going to be the same. That is, the angle of the incident is equal to angle of reflection. And this reflection of sound wave, that is the bouncing of sound wave, is what we call an echo. The reflected sound is of equal quality and loudness, as you can see here. In the diagram, you can see when the microphone is used to magnify the sound produced and there is an obstacle, the sound wave meets an obstacle and it gets bounced back. That is reflection of sound that we call echo. Determination of velocity of sound by an echo method. If the distance between the source of sound and the obstacle, like wall or hill or cliff or any hard and high obstacle, is measured and recorded, the velocity of sound may be found by using the stopwatch to measure the time taken for the sound to travel to the wall and back to the source. The velocity is given in the rectilinear motion as distance over time taken. The distance in this case is the to and fro distance. So if you represent the distance by x, it means x to travel to the barrier and x to return to the source. So in that case, velocity is equal to 2 times distance all over time. Is v is equal to 2x all over time. Working example. A boy standing 100 meters from the foot of a high wall claps his hand and the echo reaches him 0.5 seconds later. Calculate the velocity of sound in here using this observation. As you can see, we are given the distance, which is 100 meters, the time taken, which is 0.5 seconds, and the velocity is what we have to calculate, which is the unknown. So, from the relation that we just derived, v is equal to 2x all over t. In this case, x is 100 meters. When you multiply that one by 2, that will give us 200. When you divide that 200 by 0.5, which is the time, you are going to get 400 meters per second, and that is the velocity of sound in here. Example 2. A man fire a gun towards a cliff and hear the sound of the gunshot 10 seconds later. If the velocity of sound in here is 330 meters per second, what is the distance between the man and the cliff? We are given the time taken 10 seconds, the velocity, which is 330 meters per second. We have to find the distance. Using the same relation, v is equal to 2x all over t. Input all our parameter, 330 is equal to 2x all over 10. By the time we cross multiply, 2s is equal to 330 times 10, which is equal to 3,300 x. Finding the x, then we have 3,300 divided by 2, which is equal to 1,650 meters. Applications of echoes. There are many applications of echoes. Among these are determination of speed in air, as we can see in the first working example. 2. Determination of distance between two hills or cliff. 3. Echo sounding. This echo sounding is used by animals, most especially the bat and the sark. When the bat produces a sound, the sound meets a traveling insect or a traveling bird like itself during the night, and they use the sound that is received back to determine the distance of that object. Likewise, the sark, as you can see in that particular slide. And 4, detection of submarine. And finally, exploitation of oil and gas. When we use this one in the exploitation of this and gas, it's a matter of whenever in the region where the oil or the gas is suspected, we produce a seismic sound. That sound travels down and get reflected. We can use that reflection to determine the depth of the mineral. When echoes are not controlled, they constitute a nuisance. This nuisance is called reverberation, which is the multiple echoes. It can be reduced by perforating the ceiling, the seat, and the wall of the auditorium. Self-assessment. Show how the velocity of sound in here is determined employing echo. 2. A person standing 99 meters from the foot of a top building clap his hand and hear echo 0.6 seconds later. Calculate the velocity of sound in here. 3. Mention 3 applications of echo. Finally, conclusion. We are able to conclude from the video that sound wave can reflect like all other waves. The velocity of sound in here can be given by v is equal to 2x all over t, where v is the velocity, x is the distance, and t is the time. Echo is the reflection of sound wave. Echo can be useful for the following. 1. Determination of velocity of sound in here. 2. Echo sounding. 3. Mineral exploitation. 4. Determination of the distance between wall, hills, or cliff.